Okay, Jamie, so we're going to go ahead and I already set up this problem. This is that number 21 from 273. I'm going to assume you read the problem already, so if you haven't, go back and do that and then start this video. But we can declare that our t is going to be our x-axis, okay? It's our independent variable, time, and then d is going to be our distance. So you can also determine that from looking at our equation. If this is slope-intercept form, d is in our y's place, so y equals mx plus b. Okay, so there's two different ways we can graph this. Actually, let's take a look at the graph right now. I have time on the bottom on the x-axis and distance on the y. So two different ways we can graph this. One, we can go ahead and use this as slope-intercept form and take our slope and our y-intercept out, okay, for both of these lines. If we were to do that, we would go up to 60 being our y-intercept, and then it was a -7 slope, so we would go down 7 to the right 1. Let's take a look at my scale. The only issue with that is when we keep going down, because we have a scale of 10, it's kind of hard to be exact with our counting down by 7. But it totally is possible, okay, and you can keep going until you get to your x-axis. The other option, okay, and what I actually recommend for this line, or these two lines, is that we graph using intercepts, okay? And the reason I recommend that is because take a look right here. We have a -7, we have a -6, so two negative slopes. So if we take a look at what that would look like, this would be a positive slope, this would be a negative slope. So take note how it crosses both our y-axis and our x-axis, all right? So if we find our two intercepts, we can just connect it with a line, or a line segment, and we can have our graph without having to be struggling for accuracy by doing it by 1 point at a time. So I went ahead and found our y-intercepts, our intercepts already. So we already know that our y-intercept is 60 because it's in this form, but if you didn't know, you can just plug in a 0 for your x. I'm sorry, 0 for your x, which is t, and you get y-intercept of 60. I plugged in 0 for a d or a y as well, which got us our x-intercept of 60 over 7, which just is equal to 8.6 about. We did the same thing for athlete 2. X-intercept of 10, y-intercept of 60. So let's go ahead and graph both of those, and we could try to answer our final question. Alright, so here we go. Y-intercept of 60, so this is athlete 1. With an x-intercept of 8.6. Right about here. Alright, I'm going to go ahead and try and use a ruler while just using one hand. Excuse me if I'm not perfect. We know that our graph is continuous because we can be running for half seconds. All right, let's graph our athlete number 2. So our y-intercept is still 60, but now it's an x-intercept of 10. So 10, connect that to 60. Continue once again. Okay, so we now have both of our lines graphed. Because these aren't functions, we can't write just f of x, but we could write athlete 1 and athlete 2. Might be helpful in identifying. Alright, and so if we wanted to answer the final question, it says graph both miles in the same coordinate plane. About how many seconds, and it says about how many seconds faster does the first athlete finish the race than the second athlete? Well, if our bottom is time, it tells us how much time it takes them to finish. Well, this person finished at 8.6, this person finished at 10, so simply 10 minus 8.6 gets us about 1.4 seconds quicker. Okay, hopefully that helps. Yeah, and that's it.